Hello and welcome back to the Joy of Code. This is Michael again. It's been a while, a few weeks since the last episode, and it's time to make another one. I've already got a couple of questions from viewers asking whether this series will continue, so don't worry, it will. I'm not stopping. I haven't stopped. I was a bit busy for a bit with work and being out of the office, so I had a few other things to do, but I won't stop doing this. And in fact, I will try to put a few episodes out over the next week or so and see how that goes. So we are back again, and we are back with a new thing that I want to start and do more or less regularly now, and that is answering viewer questions. In the comments on the blog, there were a number of questions that came up. I've got now 2 or 3 questions outstanding that I haven't answered. And I want to start answering some of those questions in videos. So often, these answers are actually quite interesting. The questions are interesting, and the answers allow us actually to learn quite important and interesting things. And so I have decided, instead of just writing a short paragraph with a solution in the comments, every now and then when a question sounds really interesting, to pick it up in a video and make a video response about that and make an episode. So this is the first of the viewer question videos, and hopefully there will be others. So if you want to know something, write your question in a comment to the blog. I'm actually reading them and I may answer it. I may not answer all of them straight away. That depends on how it fits in with where we are up in the course. There's a whole lot of stuff that we haven't done yet. In fact, we haven't even talked about loops and arrays yet, and actually I'm quite surprised how long it took me to get there. We'll do that soon. So if you ask something that is too far ahead, I may put that question off a little bit and take a few weeks or a couple of months or so until I get around to it, but I will eventually get around to it. And if that question, if I'm able to answer it with pretty much what we know already or close to what we know already, then I will put it in and answer it. So today, the first question I've got here written down 3 questions that people have asked, and the one I'll pick is about timing. There was a question from Martin on in the blog on episode 15. That was when we were dealing still with the trick the turtle example. And the question effectively is about timers, about how to make something happen time delayed. Specifically, Martin actually asked, in our example, we were eating a bug, and as soon as we ate a bug, another one appeared somewhere else. And he asked, well, how can we do it so that the new bug doesn't appear instantly, but appears 10 seconds later? That's an interesting question because it's actually a very generic example of a timer where something happens and then we want to make something else happen sometime later. So that general principle of building in a time delay until something else happens is very generally useful. So I'll talk a bit about that. I'll bring up the trick the turtle example again, and then we'll have a look at that and see how it goes. I hope I can do that in a reasonable way. I haven't got anything prepared. That's another thing about these Joy of Code episodes. I usually don't really prepare them. I don't script them. I don't try it out in advance, and that is just because I know if I do, it will take me much too long, and the net effect will be that I just never get around to do anything at all. So I thought, I don't script them. Sometimes maybe they get a bit chaotic. So far I've usually managed to do what I wanted to do. But if not, well, I don't think there's any great harm, but at least it only takes me half an hour sitting down recording something. So let's try to get that done now. So here we have the trick the turtle scenario as we left it off. Just to remind ourselves, if I play this, I can steer my turtle and I can try around eating things. And when I eat a bug, like there, I'm now looking at eating the ladybugs. If I eat a ladybug, I didn't mean to do that. I'll probably get eaten all the time now. So what I'll do before I play that, I just remove the snakes here so that they don't get me, so that I can show you a bit more easily. So every time I eat a ladybug, a new one appears somewhere randomly on screen instantly. Oh, there. So you've seen that. What we now want to do is we want to put a time delay in. When I eat the ladybug, it should appear 10 seconds later. So let's find the code where this happens, and that is of course in the turtle, because the turtle eats the ladybug. So here is a try to eat method where the turtle checks whether it can eat something and checks whether it sees some lettuce, and checks whether it can see a bug. And if it sees a bug, it does here 4 things. It eats the bug, it counts some points, plays a sound, and then creates a new bug. And that create a new bug is where it's a method down here. That's where the new bug gets created and inserted at a random position in the world. Okay, so that's what we've got. Now we want to put in time delay of 10 seconds. First thing to realize is whenever we talk about time in a game, almost always it is much better not to use real time but to use game time. Real time is really actual 10 seconds. So if I want to say I want the bug to appear actually 10 seconds later in real time, that's actually fairly tricky and almost never what we want. What we typically want is we want to appear it sometime later in the game, but the actual time depends on the game speed. It is actually game time. So when, for example, here, if I were to increase the speed or decrease the speed, that time should actually go up and down with the other actions of the scenario. So typically we don't want to use real time. We want to use some virtual time that gets kept track by the game. And fortunately, that is actually much, much easier to do than using real time, because what it comes down to is that we can just count. So keeping time in a game comes down to essentially just counting. At the moment, we know that every actor has its act method called repeatedly when Greenfoot runs. The one act cycle, that is, the time it takes for Greenfoot to call act on all the actors in the world, we also call that one frame. So one frame is the time, is sort of the interval where every actor in the world acts once. How long a frame is determined by this speed slider here. So what we can do in terms of time is we just count frames. So if we want a time delay, let's say just we count to 100. Say, in every frame we count one up, and once we reach 100, we have waited 100 frames, and that will translate to some kind of real time. So 100 frames, we can experiment with how long that is, maybe a couple of seconds, 3-4 seconds, I don't know. We can try that out. But the point is, it comes really down to just taking an integer variable and counting. So let's look at this. That is what we will do. We will put in here an integer counter into our turtle. Make it private. That's a private variable. It's of type int, and I call it bug delay count. If I do not initialize a field, instance fields get initialized automatically, and they all get initialized to some kind of neutral value. If the field is an object type, they get initialized to null. If it is an int, it will get initialized to 0. So this initially contains 0. If we want to, we can rely on that, but I won't rely on that. Typically, it's a good idea to initialize it somehow anyway, just to make sure to document your intention as a programmer. But at the moment, what I'll actually do is I will count backwards. So I will say initialize that to 0, or I can do that actually up here, or I can do that in the constructor, and both styles are equally acceptable. I can say here bug delay count is 0, saying that the purpose of a constructor is to initialize all instance variables, so I may choose to put all the initializations together here, even though I'm also allowed to write them there, just to have them all together in one place. Okay, so I'm starting off with 0, and I say if my delay count is 0, it means we're currently not in the delay phase, counting, waiting for to insert a new bug. So here, where was it? There is my creating a new bug, and it was called from here. So instead of create new bug, here now what we want to do when we have eaten a bug is we don't want to create a new bug instantly. We just want to start the timer. Let's say I just call it new bug. I make a new method that initiates the sequence of creating a new bug, and I make a new private method here called new bug. So instead of calling create new bug as I did before, now I'm just calling new bug, and new bug is, let me just write a comment here, say initiate the timer to create a new bug. Okay, that formatting here is a bit out. That's how it should. Oops, and void I have misspelled here. So here's my new bug, and there all I want to do here is I take my variable here that I had my bug delay count, and I set this to 100. And 100 is at the moment an arbitrarily chosen number. This will determine the length of the delay, and I can experiment with this number later to see how long I really want it, whether I want to make it longer or shorter. But let's say I start with 100. So bug delay count is 100, and that means my definition is whenever that count is greater than 0, I am in a time delay counting down to create a new bug. So now in my act method here, I call check new bug. Check new bug is a method that I will make that checks whether a new bug should be created right now. And the criteria for a new bug having to be created is when my timer reaches 0. So check new bug. I will actually use my create new bug method for this, and I change the name to check new bug, and instead actually no, let me do that differently. Let me make it really separate that out, make that a separate method. So I say private void. Just to explain what I was just thinking, I thought I make one method here that counts down the timer, checks whether we've reached 0, and then creates the bug if we have. That would have worked, but just to keep my methods clean, short, coherent, I've now just changed my mind and I thought, okay, I do that in two methods. I make one method to check, count down the timer and check it, and then call this other method, create new bug, when it is appropriate, and leave that as a separate method. So check new bug. This will check whether we should now create a new bug. So first of all, what it does, it takes this variable and it says let me see. So we test this variable. If this variable is greater than 0, then I paste it here again, I decrement it. We have seen a plus plus behind an integer variable before. That was incrementing the counter. Now a minus minus decrements the counter. So this will decrement this variable, bug delay count, by 1. So I'm saying if it was greater than 0, then I'm counting down now, and now I check whether I have just hit 0 now. I say if that is 0 now, then I copy this, I call my create new bug, and then I end this. So I think, if I have thought this right through properly, that this is my whole method that I need. So first of all, I've got two if statements nested in each other. First one, let's first investigate the negative case. If the bug delay count is not greater than 0, so if it is 0, as it will be at the beginning, I skip over this if statement and I just do nothing. So in the case where my bug delay count is 0, as it is at the very beginning because I have initialized it to 0 at the beginning. So at the beginning, this method will have just no effect at all, because this if statement will just be skipped completely. Then at some stage, when I want to create a new bug, the bug delay count will be set to 100 here. From then on, every time I get in here, the bug delay count will be greater than 0. Then we go into this if statement. We decrement it by 1. And, oh, I just noticed I have forgotten a number there. So I decrement by 1. And if we're not down to 0, nothing more happens. So that will just count down from 100 to 0. And then when we reach 0, we create a new bug. And then just leave the bug delay count at 0 until I hit the new bug. So let me write a comment for this to do this correctly. Okay, so I think this might actually be complete. Let's try that out. So again, so that the snakes don't catch me, I just remove them so I can test my program in peace. And now let's try to get a bug. I got a bug, and now it's not there, and a while later it appeared there. And I got one again, and a while later it appears somewhere. That works. So that is good. Whoa, and now that was my end of my game. So that is pretty much the solution that you need. So there are a couple more things to say about this. So first of all, one thing I have said already, and that's the most important thing. Whenever you want timers, do not use real time. There is a method in Java where you can get actual real time. You can get the system clock. That is almost always not what you want. Deal with time by just putting an integer counter in that counts frames, that counts act cycles. So every act cycle, when the timer counts, you just decrement the timer by 1 or increment the timer by 1, and then you can check whether it has reached 0 when you're decrementing or has reached a certain value when you're incrementing, and then you know a certain time has gone up. Now, if you think that delay was too short or too long, you can change the value. That is quite often true that you want to experiment with these values, and that is why it's actually good practice not to spread these values throughout your code, because now if I'm a maintenance program and I haven't seen this program before and I want to make this value longer, I want to make this time delay longer, I have to search through the code and find where it is, and when I find the value I have to change it, but I'm not sure whether that value isn't mentioned elsewhere in the program as well, so that's a bit tedious. It is much better to declare that a constant and declare that at the top. Values like this that are somewhat arbitrary, like this time delay, and that someone might want to change later, we should typically declare as constant. So instead of using 100 here, I just delete this, and I call this bug delay. So I just give it a name, bug delay, and I copy this here, and then I create a constant here. And a constant, remember, is declared with private static final in front of the declaration, and then the rest looks like a variable declaration. I just say int bug delay is 100. And so, as a matter of convention, constants are typically written in all capitals, and then I use an underscore if I want to separate two words in it, and they are declared static and final. So now, by having this declared here, all the constant values in my program are at the very top of the program, and they're really easy to change. It is especially important because sometimes these constant values are used more than once in a program text, and then you have to go and search through everywhere where they are used, and that can be really tedious and error prone. You can't just automatically search and replace every mention of the number 100, because the number 100 might be used for something else. So you have to very carefully read your whole program if you sort of intersperse the numbers in your program. So you essentially want to define the number only once at the top, and then use the named constant everywhere in your program, and that is much nicer. Okay, that was essentially the explanation of how to do a timer. And with that, we are almost done for today, except that things are not actually quite as straightforward as they seem. We are now getting into the tricky area where making some changes to our program can actually introduce fairly subtle new bugs. If you think about it carefully enough, there now actually is a bug in our program, or probably a bug depending on what behavior we would want. If we assume that the intention is that we always have the same number of bugs, not errors, but ladybirds in our program. So we had 2 in our example there, and that it should always be 2, and every one I eat should come back. That is now actually buggy, in the sense it's wrong. And it takes a second to think about it to discover where the problem is. If you think about it, the problem lies in the case where you actually eat the second ladybird while you're in the delay phase of the first one. So you eat the first one, and before it reappears, you eat the other one. If you think that through, you will find out that actually you lose one of them. You will only get one back. So while the principle of the timer was done correctly, we actually have to now be very careful, and we are introducing effects that may not be intended. That's quite a tricky one, and I'll leave that up to you to figure out how to fix that if you want to do that, or I might get around to it in some later episode. But that's one thing to keep in mind, that we can actually have only, with a solution we have done, only one single timer going at the moment, and if we want 2 going in parallel, which we would want if we eat 2 ladybirds, then this all becomes a bit more complicated. Okay, but that's enough for one episode today. I'll see you soon again. Until next time, bye bye.